Unit 3 Chemistry, Chapter 4, Part 2, looking at writing half equations. Again, we should remember this from Unit 2. So if copper, for instance, is ionized to make a copper 2 plus ion, then we need to lose 2 electrons. So that's an oxidation reaction because we're losing electrons. Okay? Those free electrons could then be used to reduce another substance, for instance silver. Okay, that will gain electrons. In these half equations, notice that we have to write the electrons explicitly. Also notice that the charge has to be balanced just as we would balance everything else in a chemical equation. So if I've got a charge of 0 on the left, I need to have a charge of 0 on the right. It doesn't always have to be 0, but it has to be the same on both sides. And also notice that in a half equation, we have to write states. Everything still needs states, except of course for the electrons, because they don't have a state. Okay. We can then combine two half equations to give us a full equation. Okay. So we would combine the copper and the silver to make an overall equation. And notice when we combine them, we have to have the electrons that are being gained equal to the electrons that are being lost, so that when we then simplify it, the electrons cancel out. If they don't cancel out, then you've done something wrong. That's why this equation here is 2 silvers plus 2 electrons, giving you 2 silver atoms. We could just write it simply as 1, 1, 1, but then when we came to doing the overall, we would have to double everything in this, so that we had 2 electrons being gained, to balance out the 2 that are being lost. Now those were simple ones. If we want to do a more complex ones, we use our cohees. Yeah, little acronym to help us remember. So K is for key element. That's our first step. We balance the elements other than hydrogen and oxygen. So it might be carbon, it might be nitrogen, it could be anything other than hydrogen and oxygen in there. O for oxygen. Next up we balance the oxygen by adding H2O. Okay. Then we balance the hydrogen by adding H+. Okay. I know it says here acidic solutions. For the moment we're saying it's an acidic solution. And remember, when it's in acidic place, then what we are going to have in the environment is lots of free hydrogen ions, because remember that's what acids do, they donate hydrogen. Then we add electrons. Okay, so we've gone K-O-H-E. Yeah. We add electrons to whichever side is currently the most positive. And we add electrons so that the charge on both sides is equal. Okay. And then S in our cohees, we add states. Okay. Always have to have our states. If we are then combining 2 to make an overall equation, we then multiply each of our half reactions by some integer, so everything gets multiplied, so that the number of electrons gained is equal to the number of electrons lost. Final thing we'd do is we'd combine the half equations and we'd cancel out. So if, for instance, we had water on both sides, we'd need to cancel it out so that we only ended up with water on one side, or on no sides. We must cancel out our electrons. We might be cancelling out hydrogen ions. If it's we can't have hydrogen ion present. Instead of hydrogen ions, we have hydroxide. Okay. We'd call this cohees plus, because we add in one more step. Okay. I'd normally add it in here, after step 4. So we've done everything, we've added our electrons, but we've got some hydrogen ions there. What we would do is we'd look at how many hydrogen ions we've got. Say I've got 4 of them. I would add 4 hydroxides to the right and 4 hydroxides to the left. Now whichever side had my hydrogen ions on it, those hydrogen ions are going to combine with the hydroxide to make water. So if I had 4 hydrogens and 4 hydroxide, I've made 4 water. The opposite side, they're going to stay as hydroxide. Okay. Hey presto, I've got rid of my hydrogen ions and I've got hydroxide, so I've made it an alkali medium. But now I'm going to have water on both sides, definitely, in my half equation, so I need to cancel that out. Okay, so cancel it out until I only have water on one side. For instance, if I had a pale green solution with iron ions and a purple solution of manganate ions, and they're mixed, and we know that we make Fe3 plus and Mn2 plus ions. First thing I do is look at what's my key element. Well, I've got Fe2 plus going to Fe3 plus, so that's one of my half equations. It's a nice simple one. I just need an electron and I'm balanced. Then I've got manganese in manganate going to straight manganese ions, 2 plus. So that's my other key element, my Mn. So I'm going to start by just saying Mn, O4 minus, goes to Mn2 plus, because I've got to put the whole thing in, yeah? I've balanced my key element, my Mn, that's fine. Next up, I need to balance my oxygen. So I've got 4 oxygens here, so I have to put 4 waters on the other side. Then I've got to balance these hydrogens. So I've added 4 waters, so I added 8 hydrogens. So I balance that by adding 8 hydrogen ions. Now I've got to balance the charge. So the current charge on this side is 7 plus. Current charge on this side is 2 plus. Difference between 7 and 2 is 5, so I need 5 electrons, and they go on the most positive side. So they go on this side over here. The most positive side is almost always where you just put your hydrogen ions. Okay? And then I add my states. Now, here I'm gaining 5 electrons, there I was only losing 1, so I need to multiply everything in this equation by 5. So I've now got 5 iron 2 plus, giving me 5 iron 3 plus and 5 electrons. And then I can combine them. And when I combine them, I cancel out my electrons. Note that our transition metals can be very useful, because just like that iron there, they quite often have different oxidation states. And when they have different oxidation states, they have characteristic colours. So when we were looking at that manganese, for instance, this is what it looks like when we've got manganate, that's the deep purple. When we go to Mn2+, it changes to this light pink colour.